Okay, I'm jumping around just a little bit in your math expressions book. We've been spending a lot of time on subtraction with regrouping, understanding what's really happening there. We're ready to kind of move a little bit further because we've really built that concept strongly. Now I want to talk about what is involved in an equation, the three parts of an equation. The three things that will be in every equation is a part, and a big guy total, right? Sometimes the parts are going first to go together with adding to make your big guy total. Sometimes your big guy total comes first. Subtraction always starts with the big guy total. Big guy total goes first, then we're taking away a part so that we're trying to find the other missing part, okay? So we know there's always three things. It doesn't matter which math process we're doing, any complete equation has those three things, two parts and a big guy total. Okay, so I put three numbers up here on the board, and with those numbers we need to determine who is who. Who's the part, who's the other part, who's the big guy total. Okay, so let's just take a peek together. We've got 8, 6, and 14. Okay, so who's going to be the easiest one to figure out? The part, the other part, or the big guy total? Well, the words big guy total pretty much tell us who he's going to be. Big guy total is going to be your biggest number, right? In this situation, they've given you all three. So it's pretty easy to know that that guy is the big guy total. So let's take him and make a math mountain out of him. We know he's the big guy total, which means that the 6 is a part and the 8 is a part. Okay? Let's talk about what happens in this math mountain. These two can be put together to make the big guy total, so they can be added. Okay? The big guy total can be split up or broken. We like to use the hammer and break our big guy total into two separate parts. We can break them into the 6 and the 8. When we're breaking a total, we're taking some away and we're taking some away, okay? So now we can look at this and we can decide, we can write some equations to go with this, because we know that we have everything we need. We have two parts and we have a big guy total. Big guy total, okay? So let's look at this. I could write an addition sentence really easily. Lots of times everybody wants to start out with addition, right? So we know that to get that 14, we have to combine things or put parts together, okay? So I'd have my 6 plus my 8, and that would be the same as 14, the number 14. If I put them together, I'm going to have 14, okay? Now we know the part, that property about addition, right? We know that we can switch the part spots and the value will still stay the same. So I could put 8 here plus 6 and he would equal 14. Okay. So I took my parts and I did everything that they can do to fit the mountain, okay? Now, remember the other thing we can do. The big guy total can be at the end of an equation, or he can be the starter of a problem. And if we're starting at the top of the mountain, the only thing we have to do is to break him to make him smaller, because there's no more mountain, there's no getting bigger. So we're breaking him to make him smaller. So if we're making a number smaller, we're doing the math process of subtraction. So we have that 14, and we're going to subtract one of the parts. Okay, so you can pick this guy or this guy to go first. I'm going to pick this guy to go first, which leaves my other part left. Okay, now I can flip my parts around. The only ones we can flip around are the parts. See how I flip these around? These are the only ones that can be flipped. They're the only ones that can switch spots to make another equation that matches the same process. So now I could do 14, take away, flip them around, 6 equals 8. See See how I flipped those two around? He went here, he went here. He went here, oops, sorry. He went here, he went here. Only the parts flip spots. The total stayed at the end when we were adding. He stayed at the beginning when we were subtracting, okay? So these are all the equations that we could write when we were dealing with this math mountain. Now we can do this with bigger numbers too. So if the numbers I give you are much bigger, the process stays the same. Let me give you an example. Take a look at these three numbers. Who's my big guy total going to be? Big guy total. He's going to be the biggest number. Since I have all three, I know the biggest one's going to be it. Sometimes when you're doing a word problem, you're only going to be given two numbers. It is not okay to pick the biggest number and slap them on top of the mountain if you're only given two numbers. That won't work. You can only pick the big guy total by just looking at the number that's the biggest when you have three numbers given to you that somebody already knows work together, okay? If they're just three random numbers, they may not work together on the mountain. If they're just two numbers given to you that you find in a word problem, you have to pay attention to the words to find out whether they're the big guy totals or if they're parts. Because look, if that's the big guy total, look, my two parts that are left. One of them is bigger than this one. If I read a math problem and it only has 59 and 24 in it, it's probably still the parts, right? Because this guy would be the one that was missing. If I have a math problem and it gives me these two, I'm going to have to pay attention to the words to see what's missing, and what's missing is a part. If I have a math problem and it gives me these two, I'm going to have to figure out what's missing, and what's missing is a part. Okay, so 83 is my big guy total. He goes to the top of the mountain. I got 59 down here. I got 24 down here. Now let's write our equations. Oh, this is where your homework comes in. This week I'm giving you a little job at the end of every video. Looking at the numbers behind me, I want you now to write the 4 equations that will go with this math mountain. Go.